We are about to begin our first PowerPoint in our Acids and Bases chapter, Chapter 8. Please make sure you have your guided notes handout entitled Acids and Bases, and please fill it out as we go through the PowerPoint. Arrhenius acids and bases. So we have two different definitions of acids and bases. Arrhenius acids and bases is one definition. In this definition, acids produce H plus ions in aqueous solutions. If you remember back to that study guide we did at the beginning of the chapter, we talked about how acids could also produce H3O plus. It really doesn't matter. H plus or H3O plus we're going to use interchangeably across our chapter. So, you have an acid, HCl, when added to water, it creates H plus ions and Cl ions. They totally separate. Bases produce OH minus ions in aqueous solutions. So we see sodium hydroxide, NaOH, and when we add water, we produce sodium ions and hydroxide ions, OH minus ions. The term aqueous solution just simply means in water. So if you look at both our reactions, you see water over top of our reaction arrow saying that this reaction takes place when there's water present. Some characteristics of acids. So acids produce H plus or H3O plus ions in water. They also produce a negative ion as well. Remember in our HCl reaction, Cl was the negative ion. Acids taste sour. They can corrode metals. They react with bases to form salts and water. So anything that you can think of that kind of tastes sour, such as lemon juice, is going to be an acid. On the other hand, bases, they produce HO minus ions in water. These taste bitter and chalky. There are electrolytes, which means that they can conduct electricity. They feel soapy or slippery. And they react with acids to form salts and water. So both acids and bases react together to form salts and water. We're going to be talking about that later in the week. So this is an example of our pH scale. We're going to learn more about the pH scale tomorrow. But what we need to know today is that it's a scale from 0 to 14. And let's look at some things on the scale. The upper half of our scale is going to be where our acids are. So things like stomach acid, okay, that's gastric fluid, is very acidic. Lemon juice, you see the lemons, is acidic. Vinegar, wine, beer, oranges, tomatoes, bananas, coffee, bread, urine, milk, those are all acids. On the other end, we got egg whites, seawater, baking soda, detergents, bleach, Tums, right? Tums is very chalky. Any soap, household ammonia, which is very similar to bleach, hair remover, oven cleaner, those are all bases. So based on what we know, those characteristics that we listed, let's describe each solution as an acid, base, or neutral. Soda, many sodas can have a sour taste, right? Lemon lime soda, Sprite, okay? Soda is an acid. Remember, one of our characteristics of bases was a soapy texture. What's more soapy than soap? Soap is a base. If we think back to our pH scale we just looked at, we saw that both coffee and wine were acids. Water is our baseline, okay? Water is neutral. It has a pH of 7. We're going to learn more about what those numbers mean tomorrow, but we need to remember that water is always neutral. And grapefruits, they taste very sour. Remember that sour tasting is a characteristic of acid. So let's think back to our characteristics of acids or base. Sour taste, okay, like lemons or coffee, is going to be an acid. Our bases produce OH minus ions in aqueous solutions. Remember, aqueous just means in water. Our bases have a chalky taste. Even though we didn't mention it for acid, both acids and bases are in electrolytes. This means that they conduct electricity. And acids produce H plus ions in aqueous solutions. Remember, aqueous means in water. Here's some common acids. We have HCl, hydrochloric acid, HNO3, nitric acid, H3PO4, phosphoric acid, H2SO4, sulfuric acid, and CH3COOH, acetic acid. Now, it's a good idea to be able to recognize these as an acid and these common acids. You're going to see these again in biology and in chemistry. Okay? But what we need to make sure we know that any acid formula is going to start with the letter H, except for acetic acid. That's an exception. That's the only exception. Any formula you see that starts with an H, so like HCl or HNO3, that H means it's an acid. Let's look at some common bases. You have NaOH, sodium hydroxide, KOH, potassium hydroxide, BaOH2, barium hydroxide, MgOH2, magnesium hydroxide, and AlOH3, aluminum hydroxide. Just like the common bases, we don't need to know these or memorize these specifically, but it's a good idea to be able to recognize it. The thing that we definitely need to know, that any formula that ends with OH is a base. Okay? And any name that ends with hydroxide is a base. So acids have an H to start the formula and end in the word acid. Bases have an OH to end the formula and have hydroxide in its name. So let's match these formulas with the names. NO2 is nitrous acid, right? It has an N in it, which is nitrogen, and it starts with an H, so it's going to be an acid. CaOH2. Okay? It has the OH, so we know it's going to be a base, so that's going to end in hydroxide. And Ca is the symbol for calcium, so it's going to be calcium hydroxide. We have H2SO4. It starts with an H, so we know it's an acid, so we're looking for a word that ends in acid. It has an S in it, which is the symbol for sulfur, so it's going to be sulfuric acid. HCl, it also starts with an H, so we know it's an acid. And Cl is the symbol for chlorine, so it's going to be hydrochloric acid. Finally, we have NaOH. OH ending means it's going to be a base, so we have to look for a word that ends in hydroxide. Remember that Na is the symbol for sodium, so we know that NaOH is sodium hydroxide. Remember how I talked about at the beginning of the presentation that there was two different definitions for acids, okay, and bases? We talked about in that first, in Arrhenius' definition of acids, it produces H plus in water. Right? In the Bronson-Lowry definition, acids are hydrogen ions, H plus donors. They give away their H pluses. And bases are hydrogen ion acceptors. They take those H's. So right here, we see that we have HCl, which is an acid, and we have water. That H from HCl is going to move on to the water, the acid is going to give up its water. And here, water, or give up its hydrogen. Here, water is our base because it's accepting that hydrogen from Cl.